Hey there, Monty here with HKN with another linear controls problem. In this problem, we have a control system represented by two state variables, and we're given the description matrices right here. So the first thing we need to do is find the state transition matrix. So this question is more of a linear algebra question. So it's going to be a lot of just raw calculations. So let's go ahead and start. Here, I have the formula for what we need. So let's first S I minus A and so that's going to be our first step, is to get this. So this is S with the identity matrix. So let's do S 0 0 minus 0 1 minus 3 minus 4. We'll end up with the matrix S minus 1 positive 3 and S plus. And now we need to find the inverse matrix. So inverse of a matrix is the same as adjoint matrix over the determinant of the matrix. I'll write it out so it's clear. So first, what do we do to get the adjoint matrix? Well, luckily for us, the adjoint of a 2x2 matrix is pretty straightforward. Otherwise, we need to get our matrix of minors, and then we need to find the determinants, do the plus or minus field, and then transpose it. But there's a shortcut for us. The adjoint of a 2x2 matrix is simply this. All it is these two are flipped when these two become negative. Let's go ahead and find the adjoint matrix, which becomes S4 S, what's it, 1 and the minus. And now the determinant for our matrix is, so A D minus B A. So the determinant equals S 4 minus 3 times 1. Simplified out becomes S squared plus 4S plus 3. So now we have our inverse matrix when we put these together. Let me just put the determinant inside of the matrix. s plus 4 over s squared plus 4s 3 this one is 1 over 4s plus 3. We got minus 3 over s squared plus 4s 3. And then finally we have s over s squared plus 4s plus 3. So now we need to inverse Laplace this. So we're going to need to do partial fractions 4 times. Let's start. First, expand this into s plus 1, s plus 3. Makes sense? 1 times 3 is 3. Cool. And then 1 plus 3 is 4. Cool, that makes sense. Now, these s plus 4 over s plus 1, s plus 3 equals a over s plus 1 plus b over s plus 3. I'm going to go ahead and multiply both sides by this denominator. Play this by this and this, which makes it s plus 4 equals a s plus 3 plus b s plus 1. Now let's substitute in values to find our a's and b's. So let's say s equals -1. So we got -1 plus 4 equals a -1 plus 3, and the b is just going to simplify to 0. This, we have 3 equals a 2, a equals 3 over 2. So that's our first a. And now let's sub in s equals -3. So we'll have -3 plus 4 equals, the a is going to turn into 0, b -3 plus 1. Let's see, 1 equals b -2. So b equals -1 half. And that's our second answer. So let me go ahead and start writing out this crazy matrix. What did we say? Yes. 3 over 2 times 1 over s plus 1. And then it's minus 1/2 1 s plus 3. Cool beans. Let's do the same thing for 1. We're going to go ahead and just skip to this part. But instead of s plus 4, I'm going to have a 1. So 1 equals a s plus 3 plus b s plus 1. Let's make s equal to -1. Gives us 1 equals a 1 plus 3, which gives us a equals 1/2. That's our second a. Now let's make it to s equals -3. Guess roll. 1 equals, the a is going to go to 0, so b -3 plus 1. So this turns out to b equals -1/2. I hope I don't lose a negative sign somewhere, because then I'd be grumpy. So rewriting this, we have 1/2 1 over s plus 1 minus 1/2 1 over s plus 3. Let's do the same again for -3. -3 equals a s plus 3 plus b s plus 1. Let's sub in s equals -1. So we've got -3 equals a -1 plus 3. If we plug in -1 to the b side, it goes to 0, so we're not worried about it. And this makes a equal to -1 plus 3 is 2, -3 over 2. That's our first. That's third a. And then s equals -3 gives us -3 equals, the a is going to go to 0. So b -3 plus 1, which turns out to be b equals, what is that? -3 plus 1, which is -2, going to give us +3 over 2. Let's go ahead and write this in for us. So negative 3 over 2 times 1 over s plus 1 plus 3 over 2 times 1 over s plus 3. So now we got our last one, which is s equals a s plus 3 plus b s plus 1 let's make s equal to negative 1. So that gives us negative 1 equals a negative 1 plus 3, or b goes to 0. Negative 1 plus 3 is 2. So this gives us a is equal to negative 1/10. That's our fourth a. Now let's make s equal negative 3, which gives us negative 3 is equal to b, the a side's going to go to 0, negative 3 plus 1. Negative 3 plus 1 is negative 2, so b equals negative 3 over 2, 3 over 2, because they're both negative. And that's our fourth b. So let's plug this into our matrix. Negative 1/2, 1 over s plus 1. And then our b was plus 3 over 2, 1 over s plus 3. Now this is a little bit easier to inverse Laplace. Inverse this, we're going to end up with 3 over 2 e to the minus t minus 1/2 e to the minus 3t 1/2 e to the minus t minus 1/2 e to the minus 3 e, and then minus 3 2 e to the minus t plus 3 over 2 e to the minus 3t. And this is going to turn into negative 1/2 e to the minus t plus 3 over 2 e to the minus 3t. This right here is our state transition matrix of t. So now the second part of the problem tells us find the zero input response. So that is this one right here. Is this one. C with our state transition matrix times the initial conditions. I'm going to simplify this. Phi t equals A, B, C, D. I don't want to rewrite that every time. our C is 1 and 2. C, 1, 2. And our Q naught is 1 and negative 2. So Q one, negative 2. Let me make sure I copied that correct. Cool. So let me write down our formula again. Cool. So let me do 1, 2 times A, B, C, D. So multiplication, rows by column. So what do I get? It's equals 1 times A plus 2 times C I remember 1 by 2 times 2 by 2. These two are the same. We'll be left with a 1 by 2 matrix. So now we do B and D. So 1 times B plus 2 times D. 4. Now let me multiply this by our Q naught. That's A plus 2C, B plus 2D times 1, negative 2. So what do I got here? I got a 1 by 2, I got a 2, a 1, which is going to leave us with a 1 by 1 matrix. So I'm going to end up with A plus 2C times 1 plus B plus 2D is negative 2. This is going to be our expected, our zero input response with respect to T. So now let me write out this matrix. So A was 3 over 2 e to the minus t minus 1 half e to the minus 3t plus 2 negative 3 over 2 e to the minus t plus 3 over 2 e to the minus 3t plus minus 2 times our b is 1/2 e to the minus t minus 1/2 e to the minus 3t plus 2 times negative 1/2 e to the minus t plus 3 over 2 e to the minus 3t. Let me evaluate this. Once there's 2, I know when it gets distributed, I'm going to get rid of these. So I'll end up with this 2. When it gets distributed, I'm going to get rid of these. Let me do this side first. I'm going to replace e to the minus t. E to the minus t is going to be alpha. E to the minus 3t is going to be beta. I don't want to be writing all this out. So I got 1/2 alpha minus 1/2 beta minus alpha plus 3 beta. Let's go ahead and combine like terms. So 1/2 minus 1 is negative 1/2 alpha. And then negative 1/2 plus 3 is, so it's 6 over 2, 5 over 2, plus 5 over 2 beta. Don't forget to bring down and multiply minus 2 by all of this. So we're going to end up with negative alpha plus 5 beta Now let's do this left-hand side. And I'm going to get rid of this positive sign. So I'll have 3 over 2 alpha minus 1/2 beta minus 3 alpha plus 3 beta. Now I'm here, and we're going to combine our like terms. So I've got 3 over 2 minus 3 minus 1 alpha plus negative 1/2 plus 3 plus 5 beta. So this is 3/2 times, what is this? Negative 8/4. No, minus, or excuse me, 8/2 gets us negative 5/2 alpha. And then 3 plus 5 is 8, so I got negative 1/2 plus 2. And it give us plus 15/2 beta. We're going to substitute our betas back, or our variables back in. Our y, the I, e equals negative 5/2 e to the minus t plus 15/2 e to the minus 3t. And this is our second answer to the question. Third part says, write the expected response form for YZS of t. It says don't calculate it. So I'm just going to write out this formula. Again. Paste it eventually. So our C was what? Our C was 1, 2, and our B is 0 and 1. What else do we need? I'm not going to write out all of C again. So it's just going to be phi of t minus tau. So writing all of this out, y zs t equals 1, 2. This is a convolution in it. So I'm just going to write phi t minus tau times 0, 1, and then our u t was 8 e to the minus 4t. We go back to the top. Ut. So I'm going to sub this in for 8 e to the minus 4 tau u a u of tau d tau. And this is us writing the expected form of given state matrices. Hope this helps.